In section 8.5, we're going to be adding and subtracting rational expressions. This section can get a little bit more tedious in the sense that adding and subtracting fractions can take a little bit more time than just multiplying them because you need to find a least common denominator. And a way that we do that is by understanding an LCM, or a least common multiple. So in this first example problem to warm up here, what is the LCM of this big long expression 12x squared times y times x squared plus 2x plus 1 and 18xy cubed times x squared plus 5x plus 4? So I'm finding, again, the least common multiple. So something that could be helpful with this is doing prime factorization, which I know it's been a while since we've done that. You could do that for the numbers, though. So for 12, I'm going to do the prime factorization. So remember, I just keep dividing till I'm left with prime numbers. So I have 4 and 3. That simplifies to 2 and 2. So 12 I can rewrite out as 2 squared times 3. The x squared and y are just going to go there. And then x squared plus 2x plus 1, I'm going to write in factored form. Two numbers that multiply to give me 1, add to give me 2, will just be positive 1 and positive 1. So I'd write it like that. 18, we're going to do kind of the same thing, or this expression here. I'm going to factor out 18. The prime factorization of 18 is 2 times 3 squared. The x and the y cubed are going to go there. And then I also factor that expression, two numbers that give me, that multiply together to give me 4 and add up to give me 5 would be 4 and 1. So I have everything out in factored form. Now I want to find the LCM. And the key here for finding a least common multiple, or an LCM, is to compare everything. Or I guess first, before I do that, I'm going to rewrite this as x plus 1 squared. Now I'm ready to go. I'm looking for the highest power, okay? So between each expression, I'm looking for the highest power. That's going to go into what the LCM is. So between 2 and 2 squared wins. So my LCM would be 2 squared times 3 squared times x squared times y cubed times x plus 1 squared. And x plus 4 wins by default because I don't see it in the other expression. So this would be the LCM between those two expressions. Last thing I could do to simplify here is combine the constants here. 2 squared is 4, 3 squared is 9. 9 times 4 gives me 36. So this would be the least common multiple between those expressions. Now, this was a really long example. We won't be working with numbers or expressions this crazy in any actual problems that we do, but I think this is a helpful exercise for the next two examples that we see. In number 2, I want to find the sum of x over x minus 1 plus 2x minus 1 all over x squared minus 3x plus 2 in simplest form. So if I want to combine these rational expressions to add two fractions together, I need to have a least common denominator. I need the denominators to match up in order for me to combine those fractions. So x over x minus 1 isn't going to factor out or anything. 2x minus 1 I'm going to leave as is. This quadratic expression below, though, I'm going to factor. Two numbers that multiply to give me 2, add up to give me negative 3, is negative 2 and negative 1. So now that I have this written out in factored form, I could see what I have to multiply by to one of the fractions to get them to both match up. If I multiply that first expression on top and bottom by x minus 2, that's going to get me to have two denominators that match up. So now I have this. Again, now that the denominators match up, I could write this all as one big fraction. So I'm going to rewrite that as x times x minus 2 plus 2x minus 1 all over that common denominator. And now I'm really just going to simplify the numerator. So I'm going to distribute, combine like terms. I see the two x's cancel out. And now I'm left with x squared minus 1 on top. I know that that factors into x plus 1 times x minus 1. And now that everything on top and bottom is factored, now I can easily see things that cancel out. Here, x minus 1 is going to cancel out on top and bottom. So in simplest form, the sum of these two expressions would be x plus 1 over x minus 2. Finally, any restrictions on one variable here? For my x, again, I want to look at that term before I simplified it. So my restrictions on the variable would be x cannot be 2, because that would make the denominator be 0. X also cannot be 1. And then finally, I would be done there. Let's look at one more example dealing with subtraction. Here I have x plus 2 all over x squared minus 2x minus x plus 2 all over 2x minus 4. So, for this problem, x plus 2 is going to stay as is. I can't simplify that. X squared minus 2x, though, I could pull out a common x there. So now I'm left with that. Minus x plus 2 stays as is. 2x minus 4, I'm going to pull out a 2. So I can see here in both denominators I have that x minus 2, although one of them has an x, one of them has a 2. So I'm going to kind of multiply each other by what it's missing. That's going to give me my common denominator. So in that first fraction, I'm going to multiply the top and bottom by 2. In the second fraction, I'm going to multiply the top and bottom by x. And notice when I do that, now I get that common denominator. On both fractions now, I have 2x times x minus 2. So I can rewrite this as one big fraction. Once I get to this step, again, my goal here is just to simplify that numerator. So here I'm going to distribute. I have 2x plus 4. And then here, I want to distribute that x. Notice that I have a minus here. The only thing that can get tricky with subtraction is I feel like it might be easy to forget to distribute that negative. Think of it like I'm distributing out negative x to both terms. I will be left with minus x squared minus 2x. Now I can see that those two x's cancel, and I'm left with 4 minus x squared. And you might be looking at that and thinking, this almost looks like I can factor it, but I can't really do that right now. So I'd look at that. Right now I have a minus x squared. What if I pulled a negative 1 out of both of these? That can kind of flip the order of these numbers. If I pulled out a negative 1, I'd be left with negative 4 plus x squared, or I could rewrite it like this. Now I have something I can work with. Two numbers that multiply to give me negative 4, add up to give me 0, are positive 2 and negative 2. And now finally that this is in factored form, I can cancel out the x minus 2's on top and bottom, and I'm left with negative 1, or just negative x plus 2 all over 2x. Finally, any restrictions on the variable? Again, I'm looking at this pre-simplified problem. X cannot be 0, and x cannot be 2. And finally, I'm done.